Okay, thanks everyone for staying long enough to see my talk. So yeah, I'm Luke Stringer. I'm going to be talking to you about how you can debug your code with Git. So let's set the scene first. Let's just talk about some approaches to debugging your code. So let's say you've got some steps to reproduce a problem. They may be steps you found yourself or steps that your QA team have identified, and you can replicate a bug. How do you go about debugging that? Figuring out how you introduce that problem? Well, the first thing you can do is you can just manually look for the problem. If you can replicate it locally, you can maybe add some print statements in your code base, just see what's coming out of the console. You can add some breakpoints so you can inspect the state of the application at runtime. If you're doing this more remotely, the application only produces this problem in the live environment. Maybe you've got some remote logging, maybe using Raygun, for example. That's one approach. You can look for the problem manually. This is sometimes difficult though, for a number of reasons. It could be difficult if you don't have much knowledge of the code base. Say you're brand new to a project and you just don't know where to start looking. It could be a very complicated code base, and sometimes it's very difficult to translate where the problem is in the application to where it actually is in the code base. So you may have to translate from the pages that you're seeing down to controls or functions. Maybe that's not possible. And sometimes it's just not possible to manually find where the problem is. So another approach is to try and find when the bug was introduced. So if you can assume that once upon a time you didn't have the bug, but now you do have the bug, if you can find the point where you introduced the bug, then maybe you can figure out what you did to introduce that. And so the natural question here on this second one is, how do we do that? And that's going to be the content of this talk. So hopefully we're all using version control here. And if you're using version control, you can find the place in your code base where you introduce the bug. And you can manually go through your history and you can try and figure it out. However, Git gives you a tool to do that, and that's called Git Bisect. And I'm going to talk about that. So let's just have a quick look at an example first. Let's say we've got these, I think we've got 11 commits here or something like that. Let's say we find a bug here and we have some steps to reproduce it. We want to find the commit where that bug was introduced. And once we've found that commit, then we can have a look what changed. We can have a look at the diff and figure out what code was implemented to introduce the bug. We can see why it was changed. Have a look at your Git commit message. Maybe this references a Jira ticket or some issue tracking software to figure out, oh, this was related to us implementing some performance updates and we've introduced a bug like that. And you can also see who changed it. You can maybe go ask the developer why they did it. Very often this is yourself. So your commit message is very helpful here to have a time machine back to where you were at that point when you implemented the change. And like I said, you can do this manually. If it's a problem like this where you've got 11 commits, it's not the end of the world. You can just keep checking it out. But if you've got hundreds of commits between different versions, it can get a bit more difficult. So if you've got an installation of Git, Git gives you a tool called Git Bisect. And this allows you to automate the process of finding that first bad commit using a binary sort algorithm. And I'll show you an example of how the binary sort algorithm works in a minute. But because it's using this algorithm, it's very, very quick. So if you've got 10 commits, it will find the first bad commit in 4 steps. And it scales really nicely. So if you've got 100 commits, it takes 7 steps. Worst case scenario, if you were doing the 100 commits manually, it would take you 99 or 100 commits, whereas this only takes 7. So it's really, really nice. But for this to work, you've got to provide the algorithm with 2 control points. The first control point is the good commit, and the terminology here is good. So this is the commit where the bug is not absent, so everything's fine. And you need to give it a second control point, which is the bad commit, i.e. where the bug is. And once we give Git Bisect this information, it can figure out, with your help, where the bug is, basically. So we've got this problem here, where this is bad here. We've got a bug. We want to find out where we introduced the bug. So we'll work through an example now. So you run Git Bisect from the command line. So let's pull up a command line. Start the session by running Git Bisect. Start. First thing you need to do is you need to give it your control points. So you need to say Git Bisect bad. Now this is where the current repository is checked out. So simply saying Git Bisect bad will assume that the head is the first bad commit. If you wanted to start earlier on, you would just specify the hash. You need to give it the second control point, so the good commit. Now here we're going back in time to here. This may be the previous released version, something that's in production that works. This is maybe an internal version that does not work, and we're saying that this is bad and this is good, and somewhere along the way we went from good to bad, and Git Bisect is going to help us figure that out. So once we've started the session and we've got the bad and the good control points, Git Bisect can start using the binary search algorithm. So the first thing it does is it chops the search space in half, finds the commit halfway along the two. It then pauses, and it pauses in a similar way to if you've got a merge conflict, and it says to the user of the Git Bisect tool, is this good or is this bad? Is this bug still there or is it not bad anymore? And if we determine that it is bad, then it discounts this half of the binary search. And it says, okay, well, if that's bad, then everything is bad. And we've still yet to find the first bad commit. And you can see there it's estimating that the search space remaining has two more steps in this algorithm, and we will find the first bad commit. So it then continues, chops the search space in half once again. It pauses, it asks you to figure out if it's good or bad. When you're figuring this out, you can do whatever you like. You can run the code, you can play around with it, you can use the steps that you had to reproduce it to figure out if it's good or bad. Maybe you can run some unit tests. Do whatever you need to do to figure out whether it is good or bad. So if we determine that this is good, and great, okay, so everything before that is good, we've still got some search space left to search through. Git Bisect is estimating we've got one more step, so we continue the bisect, chops the tree in half again, pauses there, asks you once again, is this good or bad? If we say this is good, then we've finished the binary search, and Git Bisect can tell us that this is the first bad commit. This is where we went from good to bad, and it tells you the commit hash, tells you the diff. It tells you the commit message there, who made it. In this example, it was me. I can then go into that commit. I can have a look at the diff, see what I added, see what I removed, and try and figure out what I did wrong, basically. So this works really nicely. It's a bit of a contrived example, only 11 commits. But if you can imagine, if you've got a lot of changes since the last release, and you find a bug right before you deploy, and you've got 100 commits or 200 commits, this can really narrow down the search space and make it much easier. So just finally then, just a few bits of best practice to get the best results if you're going to be using this. The first one is just to have a really clear definition of what is good and what is bad. So going back to that first thing that I said, you need to know how to reproduce the bug. Now notice the terminology here isn't has a bug and not a bug, it's good and bad. You can define this however you like. If you want to find the part in the code base where where performance took a particular hit, then you could define good as being page loads in 200 milliseconds and bad as page loads in 500 milliseconds. And as long as you've got some steps to reproduce that, you can define some criteria, and then you can find the first bad commit. But you need to have a really clear definition, because if you have a flaky set of a flaky description that sometimes represents the bug and sometimes doesn't, you might find that the first commit you identify in Git Bisect isn't actually the first time that you introduce this bug. Yeah. If your definition is so clear that you can write a unit test, you can actually put that in a script, and you can pass that to Git Bisect itself. And then it won't even pause. It will just keep running this script. And as long as your script exits with a 0 or a 1 to define good or bad, then Git Bisect will basically do the debugging for you. It will say, here's the criteria for good and bad. Go off and find me the first commit that went bad. And it will do the debugging for you, which is pretty cool. I've never managed to do that. I've never managed to have the definition so precise that I can unit test it. But that's something I'd like to do one day, which is really cool. You want to try and keep your commits small enough to inspect. So if you've got a policy where maybe when you finish your pull request, you squash your commits together for a nice clear history, that's great, but it makes this a little bit harder because you lose the granularity in your commits, and you might lose the specific place where the bug was introduced. You'll probably find the commit, but it might be a monster commit. It might be the squash of 100 different commits. So keep them small enough if you're interested in doing Git Bisect, but not so small that your version control history gets ballooned in size. And finally, try and write commit messages that are descriptive. You're kind of being a bit of a detective in doing this Git Bisect. And once you find the first bad commit, you can go, oh great, this is where it is. If your commit message is very unhelpful, or it's from someone who doesn't work at your company or your team anymore, then it makes it even harder. If you can describe why you implemented a change, maybe you reference an issue tracking system, this helps in figuring out why the bug was introduced, albeit incidentally. So that's Git Bisect, and that's how to debug your code with Git. And hopefully now when bugs inevitably appear in your software, you've now got another way of squashing them using Git. Thank you.